Question number 31 says, integrate from 0 to pi by 2 sine 2x tan inverse sin x. How will we handle this one? So, tan inverse sin x, oh, this is pretty complicated in itself. We'll have to first make the substitution that sin x equals t, and do we see the derivative of sin x outside? Yes, derivative of sin x is hidden in that sin 2x. Let's write it separate by separating it out. 0 to pi by 2 sin 2x is 2 times sin x times cos x times there is a tan inverse sin x as well dx. And now I put a substitution. Now I make a substitution, put sin x is equal to t. What does that give me? That tells me, okay, cos x dx will be equal to dt. Lower limit and upper limit will not be difficult with sin x. This becomes, this 2 comes out of the integral, sin 0 is 0, sin pi by 2 is 1. Those are the lower limits and upper limits. Cos x dx becomes dt, sin x remains t, tan inverse sin x will be tan inverse t. This is dt. That's what you have. Is that okay? Yes. At this stage you realize, okay, this is t times tan inverse t. We can apply integration by parts on this. Yes. Inverse will be taken as the first function. This t algebraic will be taken as the second function. Now we'll integrate. This 2 is okay. First function, which is tan inverse t times the integral of second function, which is t square by 2 minus Maha integral derivative of tan inverse t 1 upon 1 plus t square. Integral is t square by 2 dt. This is what we are looking forward to. And the limits are obviously this 0 to 1 in the square bracket. Obviously this limit will be applied on this as well, but for the time being I have written everything in the bracket, and once I integrate this, this will be the limit that I want to put on this. So which gives me I is equal to 2 is okay in the bracket. Let's take a look at this function. This is t square by 2 tan inverse t. T square by 2 tan inverse t. Then you have 1 by 2 outside, and this is t square, right? For handling this t square, I'll have to divide first and see where does that take me. So 1 by 2 will come out, integral. I can write that t square as 1 plus t square minus 1, and in the denominator I have 1 plus t square as well. Limits from 0 to 1. Is that okay? Yes. So this 2 remains as it is again. This is t square by 2 tan inverse t minus 1 by 2 is okay. This becomes 1. Integral of 1 is t minus 1 upon 1 plus t square, which is tan inverse t. Now this here is the integral from 0 to 1. I'll substitute the limits. First let us simplify this a bit as much as possible. So this 2 from here, this 2 from here will come out common. What is remaining is t square tan inverse t minus t plus tan inverse t. Minus t plus tan inverse t from 0 to 1. Now put the limits. So this is 1 square, tan inverse 1 will be pi by 4. Minus 1 plus this is pi by 4. Minus this is 0, this is 0, this is 0. Okay, they are all 0. So this is pi by 4 plus pi by 4, which is pi by 2. Minus 1 is my answer for this question, as you can see over here. Is that all? Yes, that's all in this complete question number 31.